Hello, welcome back. We're going to do another rocket problem here in free fall motion. It'll be kind of similar to the last one. Actually, it's a little easier than the last one. But it'll be the same kind of idea. We'll have a rocket that'll launch, we'll give some information, we'll have cutoff of the engines, MECO, main engine cutoff, and then the rocket will continue to rise until it stops because of gravity, and then it will just accelerate down. So we say a rocket is launched from rest straight up with an acceleration of 29.4 meters per second squared for 4 seconds, 4.00 seconds, at which time it runs out of fuel. How high does the rocket rise? So there's really only one question in this problem, which is different than the last one. Only one question. How high does the rocket rise? It's all we care about. So we know the rocket is going to start. It's going to accelerate up, engine cutoff will happen, and then it will continue coasting up until it slows down and stops. All I want to know is how high off of the ground does that happen. Everything else is secondary. So let's go ahead and draw a picture of that. What we have is, let me draw it probably down this a little bit lower than last time. So this will be the ground down below. And then we will have, obviously, a rocket here. So we'll draw a rocket something like this, right? And it launches, goes up to the air, whatever. And then at some point up in the air, the rocket runs out of fuel. Right, we'll draw some numbers in a second. After it cuts off, the engine's cut off, the rocket stops and then comes down. Now, of course, it doesn't really turn over. I'm drawing it that way. It really goes straight up and comes straight back down again. So what I'm really interested in is, what is this height? I want to know, what is this? Because the question is, how high does the rocket rise? So this is the height that I really want to calculate, the total height. But the total height is really going to be the sum of two different heights. It's going to be, how high does the rocket go during powered flight? And then after powered flight's over, how high does it rise until it finally slows down? So there's two sub-problems in here. That's the best way to handle it. So let's write down what we know about the different parts of the motion. So right there when the guy starts, it says the acceleration is 29.4 meters per second squared, and that's upward, so that we have a positive sign there. We're going to take the launch pad, which is ground level, to be y naught. We're going to take that equal to 0 meters, right? And then initially, notice right there it says it is launched from rest. So the rocket is motionless, and then boom, it just lifts off the ground. So right there at that initial time when the rocket lifts off, it's 0 meters per second. So this is all that we know about what happens there. Then we have this event here, right here, which we call MECO, which is shorthand for main engine cutoff, right? So the rocket is going to rise to some altitude there, but then after that, it's going to continue coasting up. So what do we know about the motion of this rocket after MECO? Let's see, do we know anything? Well, we know that the MECO event happens at t is equal to 4 seconds. That's given to us in the problem statement, so that's useful. So this MECO event, I guess I should kind of draw a little arrow. That happens at t is equal to 4 seconds. We also know that beyond this point, the acceleration is just 9.8 meters per second squared, acting down. The acceleration, notice, is very different than the acceleration during powered flight, which I told you as a rule of thumb, when the acceleration changes, you probably should consider that as like a separate regime to use your equations of motion, because in your equations you only have one acceleration variable. You don't have two of them, so you have to break the problem up. All right, so we need to break it up into what happens before MECO and then what happens after MECO. So let's focus on what can we find before MECO has happened, before the engines have cut off. We know the acceleration, we know the position, we know the initial velocity. What else can